Wow, I just tried to make this video a second ago and you should have heard me. Man, I forgot I could cuss that well. Anyway, I'm back and I'm better, I think. So we're going to sketch a bell-shaped graph, and this is not a statistics question. This comes from a question from a person that said, where does that bell-shaped curve come from? And if you know what I'm talking about, it's the normal distribution curve. And I just thought, well, here's an example of what could cause some behavior like that. So I look at this curve, and while I was looking at it before, I got a little confused, I guess. I don't guess. I got a little confused. I'm no longer confused. I'm okay now. So I look at this, and I was like, you know what? As x gets increasingly big, the denominator gets increasingly big, and 1 over a really big number is a really small number, right? Right? Like 1 over 10, and compared to 1 over, I don't know, 1,000, compared to 1 over a million. So if that number at the bottom starts getting enormous, then the entire value gets really small. We also can see that this number is, this x value, whatever number we put in here, is going to be squared, so that's going to be a positive number, so we know that. So I guess my first question came, how big could this thing get? And it doesn't get very big at all. So as I did my research, I looked through, so you know what, I think f of 0 gives us the biggest number, and that would give us x to the 0 squared, right? 0 squared here. And we know that 0 squared is 0, so it gives us 1 over 2 to the 0 power. And we know that any number except for 0 to the 0 power is equal to 1. That gives us 1 over 1 is equal to 1. So I'm like, you know what, this is real weird. But as big as this function is going to get is right here. This is as big as this thing's going to get is right here. It's going to go like that. And from here on, it's going to be symmetrical to the y-axis. And it's going to be asymptotic to the x-axis. That is, it's going to, as we go to either side, it's going to approach the x-axis, but never actually get there. So look at what this looks like. So these are the values that I took. I took like f of 1, f of 2, f of negative 1, f of negative 2. F of 1 was equal to 1/2. We can prove that, right? Because it would be 1 squared is 1. 2 to the first power is 1/2. So that gives us 1/2, doesn't it? Maybe something like this. And then when I got to 2, it was 2 squared is 4. 2 to the 4th power is 16, so it gives us 1/16. And these values repeat over here because negative 1 squared is still 1. So that gives us 1/2 again. And that gives us 1/16 again here. So this thing is going to do this. It's going to kind of roll out like this, and it's going to just dip like that. And my handwriting is atrocious. I apologize. But it's going to just, there we go. It's going to dip out like that and never actually hit the x-axis. It's really, really important that we see that. So here's what a bell-shaped curve would look like. And the question was, what causes that? And we can apply some calculus to this later, and come up with some really interesting conclusions here. But this is what the question that I was asked. So this is the question I answered. I hope this video was helpful to you. If you haven't already subscribed, please do, and your comments are always welcome. Thanks very much.